original image's value.
Yep. Our original images of look.
Okay. 3, 2, 1. Hi guys, I'm Anyel. I'm Elise.
And I'm Jay.
And for our final project for Engineering 6, we chose Stenography. Our goal is to encode the data of 10 images inside one doc image without changing the original image's value too much. To do this, we implemented 3 methods: the RGB odd and even method, the color ratio method, and the RGB multiply method.
Hello, I'm Elise, and for my part of the project I did the color ratio method. Here we use this for the embedding and extracting method of the dog image. I started writing this by writing a function output image and naming that the color ratio and using it for our dog image. I made a copy of the image 1, which is the original image, named it output image 1, and made a loop of our 400 by 400 pixel, which is the dog image. And we also wanted to hide the secret image by slightly adjusting the red channel so it's barely greater than the green channel. I made a copy of this by calling this output image and naming it slightly adjusting, and if it's dark, to adjust the red channel by pixel by just 1 from 1 to 2. Creating this, I used an if-else statement. Continuing the loop, I used that if it's a light pixel, make the red channel slightly smaller than the green channel, and if the output image that we're creating is greater than the older image, then it forces the channel to be slightly larger than green, and then it's going to subtract 0.001 to the red channel. For the extraction method, when it's time to extract, I click over here, and there aren't specific numbers here, but we're going to recover the image using the zeros of 400 by 400 pixel and using a loop to check the red and green relationship, and again adjusted the pixel channels, and if it's red is bigger, we're going to match it with the darker pixels, and to make it black we're recovering it and making it equal to 0, or everything else, if that's not equal to 0, we're going to equal it to 255 pixels to make it white.
So, to implement the RGB odd and even method, I would like to show you this function right here called embed green even. So, after flattening the image, we get 0 and 255 values. We then turn those 255 values into 1s. And then we split the image in half 1, half 2, and we fold them together by adding half 1 and half 2 together. When doing this addition, we have 4 possible equations: 0 plus 0, 0 plus 1, 1 plus 0, and 1 plus 1. To help us with the extraction, to know whether the 0 belongs to half 1 or half 2, similarly to for this 1 value right here, we force 0 plus 1 to equal to 3. After that, we get access to the pixels in the even rows of the doc image. Here it means if the folded value is 0, the last 2 bits of the pixel in the green layers should be 0 and 0. Folded value is 1, then the last 2 bits are 0 and 1. Folded value is 3, last 2 bits are 1 and 0. Folded value is 2, last 2 bits are 1 and 1. And we insert this layer into the other doc image, and ta-da! We've had our embedded image. And I'd like to point out that to do this very important step, we use the bitset function. And we can repeat this to do it in the green odd rows, and we once again repeat this in the R layers, the red layers, and the blue layers.
Okay, for embedding green, for example, we target the green channel using the module function to hide the data, and we identify the pixels are dark and light. And then after that, we check that the remainder is divisible by 3 using the mod function over here. Just here. And to extract it, all we have to do is to use the mod 3 function again. The output should be 0s and 1s. Multiply that by 255. Duplicate it using red mat across all 3 channels, and boom, that is your extract.
For the extraction, we access the image green layer, and then we get access to the last 2 bits of the layer that we changed by using bitget. After that, we reconstruct it so it forms 0, 1, 11, and 10 values, and we once again split into 2 halves. We modify in half 1 into these values, modify half 2 into these values, just like we reverse engineered the steps that we did in the embedding method. We put the 2 halves together, we duplicate it by using RepMat, we turn the 1 values into 255, and ta-da! We've had our extracted image.
Hello, this is Jalen here, and this is the app that we have developed for our project. Give it a moment to load. So here we have this lovely app layout, hand-drawn by one of our group members. It's very well drawn. So there are a few buttons to check out. So we'll start off with this top row. So you can click here to import. You can import whatever file you want. We'll import the dog image. And it'll ask to crop. The reason why it asks to crop is in case that you want a bigger image. You import a bigger image, which is not 400 by 400 pixels. So this crop automatically shrinks it to the top left corner. So it's very limited, but it works. And if it works, it works. So when we crop it, it's already 400 by 400, so nothing happens. So it says good to go. It's very faint because I'm in dark mode. If you're in light mode, it is completely fine. Now, we need to load our new image. Let's pick this one. Now it asks to crop. If we try to do it, it doesn't allow us to. It says it's not ready yet because we still need to crop this here. We still need to crop this first. So we crop it and it automatically shoots it. You flatten it and expand it to make it black and white, and it's ready. So now this methods here. This next part, the methods, we just go down here. There are a plethora of options. And mode 3, sure. And then all we have to do is to click this button again. And there it is. That's our new image. Now, you notice that there is a counter on the bottom. This is edit. You can edit this to whatever number you want. 0, a big number, 88, I don't know. Let's put it back to 1. Now, let's look for the file. And here it is. This is our file. As you notice over here, it's made very recently, as you can tell. So barely anything's happened, but we still want to make sure that it has something inside. Okay. So import. Let's pick a secret one here. It asks to crop again. If you don't crop it, nothing happens. So crop it. Select the options you want. Ret mode 3. Extract. And there it is. It's pretty close. Most of the information is kept, which means this program has done a pretty good job.
This is Jalen here again. So what you're seeing now is a time lapse of the program doing its thing. I am embedding 10 images into the dog and just showing that I can extract 10 images out again. So that's it.
Not really. And that's all we have. Thank you for listening, and goodbye.